Hello, this is Ms. DB, and in this video we will go over how to do some of the problems on the Chapter 6, Section 5 worksheet, Conditions for Special Parallelograms. You should have already completed the 6.4 worksheet before you do this one. So, in order to determine if a parallelogram is also a rectangle, you can use these two theorems. If one angle of a parallelogram is a right angle, then you have a rectangle. Or if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. In order to tell if we have a rhombus, first you have to have a parallelogram, and then if one pair of consecutive sides of the parallelogram are congruent, like that means right next to each other, then you have a rhombus. This next one we use quite a bit. If the diagonals of a parallelogram are perpendicular, and in order to tell that, we might find that their slopes are opposite reciprocals. And if they're perpendicular, then the parallelogram is a rhombus. And also, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. All right, so let's look at this example real quick. It says that we want to determine if the conclusion is valid, and if not, say what additional information is needed to make it valid. So we're given some information. I already marked that AB is congruent to CD and BC is congruent to AD. And we're also given that AD is perpendicular to DC. AD is this line segment here, and it says it's perpendicular to DC, so that means this is a right angle right here. Oops, that got rather large. And then we also are given that AC is perpendicular to BD. So AC, come on, pen. It wants to work, but it's just not quite there. AC is perpendicular to BD. That means that the diagonals bisect at right angles. And we also are given that this angle right here is a right angle. So step one, and we want to conclude to see if it's a square or not. Remember, to be a square, it has to be a rectangle and a rhombus. So first we have to see if it's a parallelogram. Well, opposite sides are congruent, so there you go, you have a parallelogram. Next, we want to see if it's a rectangle. Well, because AD is perpendicular to DC, we have a right angle here, and that is enough to have a rectangle. Remember that very first one that we looked at right here says that if you have a parallelogram, which we just found out we did, with one right angle, then it's a rectangle. So we already know it's a rectangle. It's a parallelogram, it's a rectangle. And now we got to see if it's a rhombus. And because the diagonals bisect each other, it is also a rhombus. So we have that it's a parallelogram, a rectangle, and a rhombus, which means then that it is a square. Because a square, by definition, is a rectangle and a rhombus. Here's another example, same picture, but this time the only given information is that AB is congruent to BC. If AB is congruent to BC, that means that two sides are congruent, which would be nice and enough to know if we had a parallelogram. That's what 653 looks like. But remember, we can't use that until we know we have a parallelogram. And having two consecutive sides congruent is not enough to say you have a parallelogram. So you first would have the additional information you would need is either that opposite sides are congruent, whatever you would need to find that it's a parallelogram. All right, so in our examples, you're going to look at the statements and the figure and see if you have enough information for the conclusion. This is the conclusion. If not, then say what's missing. If yes, which theorem are we able to use? So in number one, we have EFGH is a rectangle. That's what we're trying to prove. Do we have enough to say this is true? Well, let's look at what we're given. We're given that FE is parallel to GH. That's what these little arrow marks mean. And that is telling us that we do have a parallelogram by definition. Definition of parallelogram is opposite sides are parallel. And we are also given that we have one right angle. So by the theorem that we learned at the beginning of this lesson, if one angle of a parallelogram is a right angle, then it is a rectangle. So this is theorem 651. So we can say yes because we do know that it's a parallelogram. So we use 651 for our theorem, and that's all you need to write. Okay, let's see if this is a rhombus. So first you have to know that it's a parallelogram. Let's see, we know that MP is congruent to MR. That's all we know, nothing else is marked. So this is, no, it's not enough information. We need to know that this is a parallelogram first. And P, I guess it would be PQRM, or maybe I should have started with M, it doesn't matter. This is, we need to know that this is a parallelogram before we can prove that it's a rhombus. Parallelogram. And the way we could find that it was a parallelogram is you could maybe say that opposite sides were congruent, something like that. That would be one way to show that it was a parallelogram. I'll just write the congruent symbol. All right, let's look at these next ones. Now for number 3 and 4, they go with this figure here. And then 5, 6, I think up to like 9 go with this, nope, just up to 8 go with this figure. So make sure you know which figure you're using. In number 3, this is all the information that is given, a lot of information. So you'll mark that on here and then decide first, the first thing to do is it a parallelogram? If it is a parallelogram, then you can go ahead and say, is it a rectangle? So first thing to do is make sure that you have a parallelogram before you decide if it's a rectangle. That's what in 3 and 4 we're checking that. So in number 4, this given information is only for number 3. So for number 4, you would erase all that if you had marked it and just start with measure of angle EFG, that's this angle, is a right angle. That's all you would know. So the first thing you have to check, is that a parallelogram? Do you have enough to prove it's a parallelogram by any of the methods given? And if you say yes, then you can check if it's a rectangle. But if you don't know it's a parallelogram, then you have to say not enough information. Would need to know that it's a parallelogram first, and then you could say one of the ways you could find that. Like opposite angles could be congruent, then you know you have a parallelogram. Let's look at some of these. So number 5 says that AC and BD bisect each other. So these two diagonals bisect each other. I don't have all the conditions to be a parallelogram on this sheet, but if the diagonals bisect each other, let's see if we can find it up here. Nope. But that was one of the conditions to be a parallelogram from 6.4. That's why I was saying it's important to do that one first and even have it open with you. So because the diagonals bisect each other, so then we know that it is a parallelogram. So that would be the first thing you'd check for. Again, it is a parallelogram. Check, yes. And then also we have that AC is congruent to BD. So if you have a parallelogram and the diagonals are congruent to each other, does that mean anything? So here we have if the diagonals are perpendicular, that's for a rhombus. And in this one we have if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So number 5 says it's a square. Well, because of what I know that it's a rectangle. In order to be a square, we also have to have that it's a rhombus as well. So let's look at the rhombus theorems and see if there's anything there that I need to know or that I could use to say that it's also a rhombus. So these are the theorems about how to tell if you have a rhombus. And I don't have anything here that would let me prove. If I knew that the diagonals were perpendicular, then I would have a rhombus. But that's not information that was given to me. So no, I cannot use this to prove that it's a square. I would need to know that the diagonals bisect that the diagonals are perpendicular. Diagonals. Perpendicular, that's the sign for perpendicular, the upside down T. So that's how you'll do these problems. You just kind of work through, and some of them will be yes and some of them will be no. And remember that you have to have enough information in order to say yes. You have to be able to, for a square, you have to know that it's a rectangle and a rhombus. So there's a lot to show that it's a square. Then on the next section, we're going to use the coordinate plane to graph and then find all the names that apply, whether it'll be a parallelogram, and then you'll have to decide if it's a rectangle, a rhombus, or a square, and give as many names as apply. You could have all three of them. So there's some examples there. You only need to choose 9 or 10 to complete, or you can do both for extra credit. So there's 9 on one page, 10's on the next page. And then in 11 through 17, you're going to fill in the table with the word rectangle, rhombus, or square that fits these conditions here, the information that's given. So I'm going to start number 10. And if you want, you can choose to do number 10 as well. You'll have a head start. So L is at 1, 2, so I'll put a point there. And M is at 3, 5. Our first step is to graph. 3, 1, 2, 3, 4, 5. N is at 6, 3. And P is at 4, 0. And then you'll connect these points with a straight line tool. I can't use my straight line tool when I'm recording very well. So that's my parallelogram. Now I want to determine if it is a, I think we're assuming they're parallelograms. Let me just look at the directions. Yeah. Okay, so we don't have to first check if it's a parallelogram. I could do that. We did that in previous lessons by checking that the slopes of opposite sides were congruent. So I need the diagonals here because I'm going to use the diagonals to determine if I have a parallelogram. So let's connect M and P and then L and N. There's my diagonals. Now I want to find out if it's first a rectangle by checking if the diagonals are equal. So we need to use the distance formula. And the distance formula, you've been doing it so much that you should have it memorized. You can look it up in your book, but you are going to add the x-coordinates, subtract the x-coordinates and square it, and then you're going to subtract the y-coordinates and square that. So for Ln, here's L and here's N, I have the points 1, 2 and the point 6, 3. So I plug in, and then don't forget to do this part, fill in rectangle, rhombus, or square in this. Find the best answer, the most specific answer you can. All right, have a great day and let me know if you need help on any of this.